Test 1 2 1 2 sound. Okay, maybe a little more. Yeah, should be fine. Hello, hello, hello. We have sound. I need to start music. I just got home, so I'm a little bit behind. So give me a second. Let's go with midnight today. And what's going on? Why can't I? Okay. Hello! Hello, Diogo. Sorry. Okay. So we have chat, we have sound, we have music, we have camera, we have everything. Welcome, everyone. Nice to see you. Sorry, I'm a little bit late, but this is what it is. So I need what? I need to. No, not next project. Next after the Milo. First the Milo, then the robot arm. Let's start the banner. Let me start my V0 because I need to print something that I completely forgot. So let me change the angle on this guy. Okay, not that much. Should be something. Okay, I have this 1 2 for that side. Yeah, we are good. Yeah, we are good. Well, yeah, that's a thing. That's the thing with everything. It's always spend a lot of money and not that much coming in, at least for me. But it is what it is. I'm only doing them. I don't even need a Milo, to be honest. But, well, we're gonna have some fun with it. I always have fun, and I always gonna have work for it anyway. Hey, Beanie, how are you? Okay, let me grab my power bank. So this thing is this vest here. Yeah, I'm good. Well, I need to check how many I have because that robotic arm is gonna need 2 of those, and so probably not anymore. But we'll see. I'll need to check because I know I have a few of them, and I only need 2. So if I have 5, I can spare you 3 of them. I need to check. Actually, I can check in a minute. Give me a minute. Give me a minute. Okay, so what do I have here? Of Nemo. Because I used one on my big machine as well. Well, but how do I only have? Do I have them? Oh, okay. I have 3 assembled, 2 assembled here. No, I can. Oh, we'll see. I need to see. Yeah, I'm good, Vinny. I'm gonna. So I was saying this vest is actually active heated. So, but it needs a power bank. Today it's not that cold in here, but it's gonna be. But these steppers are supposed to be cheap anyway. At least they were at the time. So if I press these two buttons, well, what happened? Yeah, here on my shop it's 12 degrees, but the printers they have been on, so not sure. Yeah, there we go. So it's a little bit hotter or less cold in the shop, but outside it's something like 5 or 6 degrees. Anyway, so welcome everyone. Good evening, good morning, good afternoon, good whatever for you. Back to the Milo. Yes, I was saying, what happened here? I need to connect my V0 because I need to print some stuff. Turn on the dryer. It's fine. My V0 is on. I need to print. I completely forgot to print the LED the diffuser, so I need to print that. So meanwhile, while this thing gets on, where do I have the transparent filament? It's here, so I only use this thing for the diffusers actually. And actually I think I need to clean the nozzle first. I need, where is my, it's here. There we go. So let me take care of that. It only takes a few minutes. So let me put the temperature to 60 so I can clean the nozzle. Shit. Lot of filament left here. So I'm not sure what kind of nozzle I have on that thingy, so I'm just gonna push in There we go. Let me start the bed. 16. Extrude. Load. Spit out the filament. How is it? A little more. Yeah, looks decent. Retract. 120. Still a little grayish. So let's extrude some more. Hey Marco, again? Man, you need to be clear. What you... Is working the 2.4 with lift bar? What do you mean? If my machine is working, well, the machine is working, only the hot ends are not. Hey Joseph, I need to lower my volume a little bit. Seeing a little clipping. Actually, I was working on it today a little bit, and I need to make a new video on that thing because I made some configurations wrong, and I noticed it a few days ago, and I found out actually early today how to set that thing properly. So everything I did, it's kind of fine. On the streams, yeah, the Skyla monster, but it's not absolutely correctly, especially if you're printing with well, if you're not printing with the tool 0. So if you start a print with another, let's say you have a bunch of, well, let's say you only print with tool 2, you can do that. But with the way I did the configuration, I can't. It's wrong, the offsets are wrong, and I figured out how to properly set them. Okay, retract. And cool down. Yeah, it's good. So what I'm gonna do, I need to start Orca. It's on the wrong monitor, so let me push it here. And let me show Orca, which actually properties, same acceptable, okay, fine. Okay, so new project. Everything should be fine. So let's select my V0 I need to set the IP address because this is a new setup on my computer. Let me check which one is the IP. It's the 202, so I need to put in here 202. So okay, so we need fiber logic, no, filament, I think it's filament, it's PETG, so where is it? Yeah, transparent, so it's this one. So let me add the model, 3D printer, models, not models, actually machines, Micron, R1, STLs, antennas, and diffuser. Okay, so that guy, let me auto, well, fuck you, not like that. Well, to be honest, kinda should be. And I don't like to print just one of these, so I'm gonna go Control K and add a few more. Uh, 02 should be fine. Standard, I'm gonna put it slow. Quality slow. 02, make sure. Slice. So yeah, it's gonna take like 10 minutes, which give us time to talk a little bit. And print, upload. Let me take a look at it. And yeah, okay. So it's heating up the bed. Okay, so let's talk a little bit while this thing prints. Should be fine. PETG, so we don't need to close anything and whatsoever and wait for chamber temps and whatsoever. Anyway, so okay, we decided that yes, my Scala has 2 PSUs. You can argue that you don't need 2 PSUs. I decided that my Scala would have 2 PSUs. So in theory you don't need, but it doesn't hurt. I prefer to have 2 PSUs working at 50% each one than have just one PSU and work at like 80% of its power. So yeah, I decided to go with 2 PSUs on my Scala. But on my stream I say you don't need to. I just find that it's better too. Well, I decided that I wanted to. It's not that it's better or worse. I believe it's better. Some may argue. Okay, it's printing. Looks good. As expected. Oh, actually it doesn't look that good. Yeah. Cancel print. It's not main menu, move. I need to clean my build plate. Let me set the temperatures so it doesn't cool down. Ah, I hate this touch. Yes. Probably we messing with the fingers on it. Doesn't like it. Set to 1. No, I work at 1. I work at 120 volt here in Portugal. It's Europe actually. It's 120. It's 220. Sorry, not 120. 220. Actually, it's 240. What is my alcohol? I thought it was here. It's not. It's here. So, but yeah, it's just. It's too much power, because if you have a 500 or a 1000 watt power supply, it doesn't mean that it consumes 1000 watt. It means you have 1000 watt available if you need to. So it's better to have 1000 watt and only using 300 of it, let's say, or even 400, than having a 500 watt power supply and actually use the same 400 watt. So yes, if you're using, it depends on meanwhile, actually, they have good power supplies and they actually have the specs. They are rated. So they actually meet the specs they say. But yeah, the cheaper ones, I tend to go on a higher value for it. So if I need a 500 watt, so if I have a project that needs 500 watt of power running, so I usually go for the 80% rule. So I'm gonna calculate that 500, it's actually 80% of the power I need, or more. So let's say we do the math and we need a 650 power supply. Probably I'm gonna get a 800, and if it's a cheap one, I'm gonna get like a 1 kilowatt or even more. On Milo, I'm gonna use a cheap one, a 60 volt cheap one. Don't care, 600 watt, I believe. I never had any problems. But again, just because you have a 1000 watt power supply, it doesn't mean you're gonna use 1000 watt. You can have a 1000 watt power supply and only use 1 watt. Doesn't matter. What's the advantage? Well, the advantage is you're gonna run a much more a much more efficient area, so you won't have as much heat, which means you have more efficiency, so it works better. So I have 2 power supplies on my Scylla. Not really. Maybe when you turn it on, but after it's running, it's the same. The more watt you get from it, it may generate more noise. The more current, actually, the more current you get from it, it may generate more noise. That's a thing, but that's with everyone. Even meanwhile, some just deal with the noise better. And when we say noise, when I say noise, I mean electrical noise, not acoustic noise. So let me start this thingy again. Print. Adapt to load on temperature and even on coefficient and whatsoever. But yeah, as I was saying, I decided to go with 2 power supplies on my printer because I prefer to use less. So I prefer to use a big power supply using only half its capacity than an adequate number, or let's say if I'm going to use 500 watt, I can use if I'm going to use 400 watt, I can use a 500 watt power supply, but you're going to run on 80% of its power. And if you use a 600 watt or a 70 or a 1000 watt power supply instead, you're going to run the power supply is going to run much cooler. So that's why I decided to go with the the second power supply, even overrated, because I believe it's a 350 watt only for the 6 tool heads. And then you have the factor of so what we call the coefficient, how is it called, like the common coefficient, which means even that I have 6 heads, how many of them are going to be on at 100% at the same time. So that's there. So because usually they are on standby, and actually even they are on full power. After the hot ends only get full current pretty much when they are cold, because when they start to heat up, the current starts to go down, and when they are full heat up, they are just getting spikes to keep up the temperature. Yeah, I think we are good now. We'll see. So yeah, do I need 2 power supplies? No. Did I use 2 power supplies? Yes. That's the point. Let me turn on this camera, which I haven't yet. Okay, I need to power on the... There we go. Okay, so what are we gonna do today? Today we're gonna go assemble the head of the printer. I should add watch the last, oh, not the last stream, the other one. Yeah, exactly. I should have watched the episode 6 to see where we finished. I forgot, or better say, I had no time. So, but I assume we need to start going to the ad. We can also open the documentation, which I'm not sure if the manual is out already. Probably not, so most likely we are on our own. Probably we're gonna need the CAD. But anyway, we're gonna need, so I have a diffuser flying already. Hopefully the other 2 survive. I need to wash that build plate with actually soap and water, hot water and soap to degrease it. Hopefully we're gonna have a successful print, or maybe not. Shit. Probably I need to go. What's going on here? Usually. Oh, I see. I see. Most likely the problem is another problem. I think we have another problem. Either my filament is too wet, which is a possibility, or I need to do some changes here on a slicer. Cooling. Oh, okay. Yeah, I have some. Where is the... Yeah, okay. I see. Okay, I had some mistakes in here. So this can be 100, layer time 10, 20, save. Okay. Let's try again. Print, put in print. Hey, Trurex. Oh. Oh, the burnt item. Shit. Well, someone said they had that problem as well. Shit, that sucks. I'm kinda glad that I couldn't make the burnt titanium work. Because probably I would have the same problem. Yes, I milled titanium. So I actually made an air rifle, so a BB gun out of titanium. So yes, I have some experience with titanium. I milled and I turned titanium. And grade 5, which is the toughest one. So the 6 AL4V. So it's pretty much 60%. I don't know the numbers. I think it's 6% aluminum, 4% vanadium, and the rest is titanium, something like that. It's the strongest one, grade 5. Okay, so I printed the well, I machined titanium with my router as well. Just not as much, but I did. What you need to be careful with titanium, you don't want it to burn, because that thing is super hard to put out. So you want coolant on it. So the most I machine titanium for, I make some specific custom screws, and I need to mill well, I have to open the threads, but that's on a lathe. Yes, mist is perfectly fine. I use mist on my router. But use a wet mist, so open a little bit of oil more, so you get a more wet mist. As I was saying, most I do is machining with very, very small mills to machine Torx, T20 T30 Torx. Let's see. I think I had too much coolant. And do shallow passes like in aluminum, like deep, shallow passes. Should be fine. I don't think it's too hard. Of course, yes, it's hard if you have to machine a part like this of a chunk of titanium. That's going to be hard on your mills. I'm not sure what you need to do, but I'm pretty sure it's not something like that. And if it's grade 2, it's much softer. Grade 5, it's awful. It's very tough. It's going to be very abrasive. You need some good mills with good coating. Otherwise, it's going to run through mills like it runs through matches. It looks good so far. Let's see. Yeah, it depends on the part, but it's definitely not the easiest material to work with. I make, what more do I make? Usually I don't make much titanium. I make some screws. I make some shafts for a device I sell. Lately I made some, well, I can show you what I made. Titanium. Stainless steel, it's another thing. 304, it's a pain to machine because it work hardens. 303, it's amazing to machine. It's like butter. So stainless, it's a whole new thing. Okay, let me open Brave. So if you go here to facebook.com/BMS Precision, yeah, fuck off. I don't care. I just want to see. So this is my page. So here, yeah, there's no titanium here. Let me zoom in. Fuck off. Do I need to log in? Motherfucker. Okay, so give me a minute so I can actually let me do something else. Here I should be. Yep. Ah, really? Oh, fuck me. Okay, it's case sensitive. That sucks. That really sucks. Fuck me. Okay, I need to go to other printer. Or probably... I'm not even sure if it's the printer. Pretty sure it is, because I had a problem with the last ABS prints I did as well. Well, that's true. Better now than... Okay, let me heat up my Trident then. Big screen, okay. Okay, so let's go to the 303. And heat bed to 65, extruder to 270, so I can clean it. Okay, give me a second. I need to go to that printer I need to remove those parts and set this thing. So I'm here. I'm just not on frame. Yeah. Cleaning the nozzle. Shit, I really need to fix the lighting on my Trident. So extrude, cleaning the nozzle. Should be fine. More fan, part fan, so it cools faster. First time I have some kind of adhesion problems with PETG, but since I had problems on my last print as well with ABS, I need to proper clean that thingy. Okay, so let me go to work again. Let me change the printer. So Trident P 0.4 nozzle. Let's Discard for now. Yeah, we can go quality slow because speed is transparent, likes to go slow. Filament preamp transparent. Oh, nope, not what I was expecting. Let me check cooling. Yeah, that's fine. Yes, no fun. Yes, that's it. So slice, print, close. Okay, so let's go. We were watching no, I don't want to see any notifications. So let me go to my page. Okay, so we're watching this thingy. Let me zoom it a little bit. Okay, so this is aluminum. So this gun, so everything there, it's titanium. That is titanium as well. I have some more pictures in here. Actually, this pillar here, it's titanium. This thing is very small. It looks big, but it's small. So here it's everything, it's aluminum. So these wheels actually are titanium as well. So this is titanium. So those are these little wheels there. So titanium it's a pain to thread or to tap. If you're tapping, you really want to make sure if you either are form tapping, or cutting threads with a treadmill. You definitely don't want a regular cutting tap for titanium, because titanium it's kind of elastic. So trust me, it's a pain. So tapping, you really want to form tap or thread cut the threads. You don't really want to mill thread or mill cut the threads. You don't want to tap it with a regular tap. So what more do we have here? So here everything is aluminum. So this is the anodization. So that thing is also titanium. So yeah, this is titanium, all of these. This is a stock aluminum. So this part here is also titanium. So that's no titanium. So this was the machine, the 4-axis machining. It was a fun project. It was a fun learning experience. It was the first time I actually machined proper titanium. Other than this, pretty much all I did was some screws, some small stuff. So yeah, let's see how is it going. Let me check. Let me go check. Actually, I think my problem it's no, should be fine. Should be fine. Should be fine, I think. We'll see. Okay, so let's let it print. And let's go to the main camera. Okay, so yesterday I redesigned, well, I didn't redesign anything. So I just put my LEDs on this thingy. Let me, where is the focusing? There. Yeah, there. So I did the LED mode for this thingy, and I reprinted everything. A new fan grill, all the need some hot air in here to take some of these spider webs. The extruder parts. So I machined everything. So this is the tension arm, fits like a glove. I just forgot the diffuser. What else? Where are the? So I have the LEDs in here. So this is the same wiring I had on the other head I showed yesterday. So actually I test fit the LED in the carriage, fits just fine. So I assume this wiring will work fine for this setup. I'll need to pass the hot air gun in here to clean the whitey spots that we have from the texture plate. We're gonna do that in a second. Let me grab the hot end mounts, which were actually I think it's my filament, it's too wet, but I'm pretty sure we're gonna get at least one good part out of the 4. So I printed both, the proper one. I don't understand why, at least on my. So these ones. So this is for the Dragon, and this one is for the TZV6. And I'm going to use a TZV6. What I don't understand is you guys can see. So like this, yeah. So this one is deeper, and at least my TZV6, it's the same height as the same length as the Dragon. So this means this one will sit higher on the head than this one, even, and I don't know why, but so I actually printed both to compare because I wanted to use the one that it would sit higher. So I'm gonna go with the proper TZ one. So this is the TZ hot end. And this is a dragon. Hot end. This one is much heavier. And yeah, and I measure them with the calipers, and they are the exact same height, even that the mount is at least 2 millimeters 2 millimeters higher than the one from the dragon. So I'm not sure if it was a mistake or whatever, but yeah, I'm gonna go with that. So that one goes away. We can actually start assembling this thingy while the printer prints. So I'm gonna check the printer again. Fuck. No. I think my filament is too wet for this because it failed again. I don't think, I'm not the most experienced guy with PETG, but I don't think coolant is a problem with this. So, but I will do another try. I will do another try. Oh yes, I hear small pops. I know it's wet, I know the filament it's wet, but usually it prints just fine. So what I'm gonna do, I'm gonna take off the coolant out of it. I know it's wet, but usually it's always wet, but so what I want, I don't know, let me check. I'm using something like 60%. I'm gonna drop it to 20 because on these parts doesn't really need. The only PETG parts I print pretty much are these parts. So yeah, I can say I'm not coolant. Actually, I'm on 80%, so I'm gonna drop to 30%. 30%. Let's see. And since I'm printing slowly, I'm gonna actually drop down to 20%. It's a stealth burner, it's not the most cooling thing in the world. So let's try again. Other than that, I have another filament I can use, which is sealed. So let me check if the nozzle is clean. And I'm gonna actually close the windows. Usually PETG, let me check something. What bed temperature you guys use on PETG? I'm using 65. Same as about PLA, because it's what I read should be fine. So first time I'm having these problems actually, because I printed a lot of these diffusers and never had a problem. 80? Okay, and I can override it. But the filament is as old as my oldest printer, so the filament has 6 years. And it's never been sealed. And PETG is actually very hydrophobic. No, not hydrophobic. Hydrophobic, it's the other way. It repels water. So it absorbs water. Okay, I'm hearing a car. Let me check. No, it's a plane, not a car. I live in the middle of nowhere, so a car at this time, it's not usual. So yeah, the filament is probably too wet. That's why I'm having problems. I always use these settings, never mess with it. Oh yes, I did. I showed it yesterday on the stream, but I can show it again. So my verdict is, well, you can see for yourself. So this is the original one. This is the fake one. The only thing I find, this one is a little more play on the jaw. Let me, other than this, see. This one barely moves. This one moves a little more, quite a little bit more actually. But as I said, this one costs about $65 or 65 euros, and this one costs 15. So I think this one for the 3D printing use works just enough fine, or actually quite enough fine. Yeah, other than that, it's just the finishing on the original is more matte. This one is more shiny. I'm pretty sure the tolerances are much better on this one other than this one, but again, it's like a $50 difference on a $65 product. I would say this one for my needs on this shop is just fine, and I have 3 of these, so I know they are worth the money. But yeah, you can get the full set of these for the price of one of these, and I know what these are capable. I don't know about these because I received it like yesterday or 2 days ago. But yeah, for this kind of stuff, pressing magnets and whatsoever, I trust this thing will work just fine. Now, if you're talking of tightening M12 or M16 nut with this, I'm not sure because I haven't tested. So that's everything I can say so far. Now take your own conclusions. We are talking about a $50 difference on a $65 product, which is huge. And whatever you're gonna do with it, it's gonna dictate if it's worth or not. So I'm not sure yet. I haven't tested this thing enough. It's just from what I'm saying, it's from feeling it. But yeah, for 15 bucks you can't get better than that, to be honest. So it all depends on the quality of the steel, which I'm not sure. This is chrome vanadium, and This one is Chinesium. It can be good, it can be bad, I have no idea. I haven't tested enough. I haven't stress tested, but again, for this kind of work, I'm pretty sure this will work just perfectly, just as good as this one. Now for the weight-wise, I would say they weight the same. I actually have a scale in here, so we can actually check. So the original weights 230. Why is this thing? How the hell? Oh, okay, that's new. Okay, so this thing, let me zero it. So this one weighs exactly 230 grams, and this one 232. So I got it from AliExpress. If you go to my Discord on the tools, I put a link there. So, but yeah, they weight the same. They don't look exactly the same, but they look kind of the same. You can actually see the original one, it's more refined. The castings are smoother. The tolerances are better. But again, for the price difference and for these use, I must say I would probably buy a set of these instead of one of these. Now for hard working, I don't know how these behave. I can do some stress testing. Worst case scenario, I'll break it, but I can try to tighten some good screws with it and see if anything gives in or whatever. I don't think it will, but it's what I can say. Okay, let me check if the thing is going better now. Yeah, I think it is. Everything is still stick to the... So probably was too much coolant together with the high humidity of the filament. Was the perfect storm, I would say. Okay, so we can go assemble this thingy. So let me grab my share. Let me aim this thingy a little more to here and lower. There we go, so you guys can see my ugly face. Go, so this is the Autent kit. Comes with pretty much everything for like 18 bucks or something like it. Not sure. It doesn't even come with the V6 stupid adapter, the Groove adapter, which in my opinion they should have a version without this and cheaper, because who the fuck uses this thingy? So we're gonna use the... I'm not sure if the wire's gonna be long enough. Oh! This actually uses a 104 NT4 to thermistor, I could swear it would be a 3950. 3950, is it? I think so. Okay, so I need first to do some stress mark thingy with the hot air gun. Need more power. So for those that don't know, this will remove the white markings from the stress marks on the plate, on the build plate. I would try to show it on camera, but it's very difficult to actually show it. So this doesn't matter because it's on the back side, but since we're doing it, let's do it all. Let me use on this one to remove some airs, strings from the printing, so that's fine. This is fine as well. This doesn't matter, it will be fully even. Yeah, it should be fine. Yeah, everything looks good. No white marks, no nothing. So now, so this thingy should go in there. Oh, actually I can use it. Okay. I think, yes, I can use it. I thought it would be like in the stealth burner, which the wires all need to come from the bottom, but actually we can use it like this, which was like I initially had him. So this is my own design with the LEDs, which I'm going to be sharing once I see everything works as it should. So these are the same LEDs that the how is it called, the XOL. So these are the NeoPixel sequins. So it's the same as the XOL 2 LED uses and the mini stealth burner. So I decided that they should be good as well for these tool head. Okay, printer finished. I need to go check if everything is fine. So they just press fit into place, I think. At least they should. They need a little bit of Portuguese persuasion, but I need to be careful because this thing is a little fragile. Need something less pointy, like an Allen key or wrench or whatever. Okay, that one is fine. So the idea is exactly that, to be a snug fit so they don't move away, and looks like we got it. Now I'm gonna leave it. I'm gonna grab I'm gonna check the thingies, see if they are good. Oh yeah, they are good, all of them. All of them survived. Well, they look good. We'll see if they are good or not. So all of them survived. So let me choose one. Will be which one will be the lucky winner? Oh, fuck me. Shit, I printed the wrong... Fuck, I printed the wrong... I printed the Voron one instead of the... instead of the Micron. So I'm gonna print the... shit. I'm gonna reprint these thingies with the... so the Voron ones. But I want to use the Micron, not the Voron one. So later I'll change it, or probably not, because I know myself. Shit, and it takes a long time to print that part, and I even need to change it because I only modded the original one. It's easy. It's an easy mod. I can actually show how I made it so like modular. Fuck, so... oh, god damn me. Okay, let's see this thing again. 65, 120. Jesus. Okay, so what I need to do, I need to grab the right ones. Which they are where? It should be in here. So STLs, LEDs, diffuser for Voron. Jesus. Looks like the camera is happy. Usually it hiccups, but not that much. Okay, so let's download it. Let's Orca it and import it. Let's clone it. I'm gonna make only 2. Slice. So it takes half the time. No, actually, this one it's a old Panasonic Lumix bridge camera, which I loved, but I dropped it on the floor and it didn't like it, so I need to buy a new camera, but hey, it's working. So I think I need to drop it again to see if I either fix it or I break it for good, because while it's working, I'm not seeing buying another camera. I'm pretty sure it's the stabilization system that went kapoom. The problem is I deactivate it, but it keeps coming with it, which kind of makes no sense. But yeah, it's a 50-50 chance. Oh fuck. Anyway, we're gonna prepare everything. Oh, Jesus, I'm pretty sure this thing's gonna die in here with the Micron, with the Voron instead of the Micron logo. Especially because I don't have another attend, because if I had another, well, we'll see. We'll see. Okay, let's assemble the attend while the printer is going. So this thing comes with everything, like thermal paste, but I'm not gonna use this thermal paste because I have a pot open and it even brings the X key for assembling it, which is kind of cool. Okay, well, I'm seeing here 2 set screws. What are the set screws for? So it comes with the small countersunk screws for there. I don't see. It's probably, well, I don't know. Yeah, I have a bunch of them, but not like this. Oh, it's there. It's for the. Okay, I see. It's for the heat break. Okay, I see. But it has it already. So I have the other model, the ones for bamboo. It's the model I have. So with the squarey, thingy, not this round one. And I actually bought this one just to check it out, because I was intending to use the bamboo ones in here, but it's not compatible with the with this head. So yeah. Anyway, so let's get the screws. And she's jumping again. Let's see if it stops. Oh, it stopped. Yeah, the Undead looks really cool. I haven't tested it for its performance yet. So it comes with these kind of ECAS plugs, probably for something, for bamboo or whatever. Extra set screws, looks fine. Comes with a spring. Let me grab the, actually it's here. So this is GD007 or GD007. I like it. I use this stuff a lot. I went through at least 3 of these little pots already for other stuff I make, item stuff, and it works very well up to at least 300 degrees, so I know this stuff is good, or at least good enough for our purpose here. So I'm gonna put a little bit in here and a little bit on the hole where the how is it called? The thermistor will go. Wake up, my friend. So just a little bit there. Should be fine. Then we go with the little thermistor. It goes in the hole there where I put actually I'm gonna dip the thermistor in this stuff. And shove it there. Then the heater, same story. Yeah, it will spread just fine. Like that. And now there's the spring, which has some recess on the sides, so the wiring of the oh, okay. So the wiring of the thermistor comes on the side and it has a recess, so you can put it either way, like as long as the recesses are to the side of the thermistor. Makes quite a bit of force. Like that. You want it on the middle. Let me clean my finger. And I'm gonna actually clean the excess of thermal paste. Because if I don't clean it with a piece of tissue, I'm gonna clean it later with my fingers. So it's better to clean it with a tissue. I think it was AZ. It was you, right, AZ, that spoke about the flash forge titanium burn titanium failure as printed as 3D printer parts. Pretty sure it was you who spoke about it. So our friend TrueRex had the same problem. No, it wasn't you. I'm not sure. I know it was somewhere from that side of the world that spoke about it. I'm not sure exactly who was then. Maybe questionable choices? Not sure. Okay, so as I said, I'm gonna use this guy, and this guy, it's gonna be in there, and it fits, which is awesome. So we want the wirings to come on the back, and this is the back. Yeah, I remember someone mentioned it. Not sure. Okay, so it needs the little more dings. So we want it like that, aligning the holes. And it finished. Okay, it grabbed. That's fine. Let's put the other ones. So yeah, flash forged. Ooh. On which printer? 2.4 Micron. These are good-looking heads, in my opinion. Nice. Okay, so everything is in. I'm gonna screw them in, tighten them in properly. So these screws are really easy to strip. Oh, actually, we need to get the stealth press. We need some... Okay, so the silicone, or kinda... This is kind of hard silicone, to be honest. But it's still silicone. It has a slot in the back to... Let me see if I can show there to the yeah, I was asking about AZ Cowboy one, so that's for the wires to come out. Let's put everything in. Okay, I need some alcohol to properly clean my fingers. Yeah, that's fine. It's gonna get messy anyway. Okay, so let me grab the stealth press. Let me remove this box of connectors away. My phone stand. This guy needs to be out of here. It's from another sink. So these two, it's gonna be for the spares. I'm not gonna use them. This is gonna be to the garbage, which can go to the garbage actually. Let me check the prints. First, let me start the stealth press. It's connected. Yes, it is. There it is. Do I have the right? Yes, I do. There we go. It's fine. Looks decent enough. I printed two just in case. We don't need the thermal paste anymore, so move that away. And a little spatula. Yes, definitely it's wet. My PETG. A lot of spider webs in here. So I need hot air to get rid of them. Jack, I told it before. If you go to Discord, to my Discord, I got them on AliExpress. But if you go to my Discord, on the tools and whatsoever channel, I posted a link there a few days ago. Just look there, it's there. Much better. Okay, let's see if it fits. So this thing looks like it's not centered. So looks like it's this way. Oh no. Actually, we need to fit it first on the I have this part as well. Okay. Yeah, that one will take a little more. We don't need a heated chamber for that thingy. God damn it. Actually, it's 100 degrees on the bed. $260. Completely forgot about that one. Okay, so the transparent one, it's done. Put in the black. Cleaning the PETG. Where's my tweezers? Probably I forgot them. Of course I did. I'm building the Anted. So it's a custom Micron ad. Well, now it's actually even available for the bigger printers, the MGM 12 carriages. Since people liked it so much. It's not the best performing one, cool one. So, okay, prepare, delete all. Let's load in the Antes. Let's paste here. So we want the light shield. Oh shit, I don't have it here. So I need to download it first. So we want the light shield for the Voron. Download. So again, we want to download diffuser Voron. Let's copy it to the Anted directory. Paste. Oh, no. Skip. Light shield Voron. Copy. Paste. Light shield. Let's print 2 as well. So Control K, 1. Let me change to ABS high speed black. Oh, okay. So the link is in the description for the Discord. Yeah, it takes 3 minutes to print. Okay, let me change real quick. I don't want to wait for the chamber temp. So let's go with it. Even that we should be close, not even. Okay, meanwhile we can do some inserts. This thing takes a few. So if I'm right, actually I have one in here that I had assembled before. It's an early version, but should be fine for these. Okay, so we have 5 on the top. So 1 in here. Let me put this a little bit more in frame. There. We have 1 in here. good. Oh, it says expired? Well, glad you said that. Okay, I'm gonna... Give me a second then. It shouldn't be expired. I set it to not expire. But give me a second, I'll copy. So invite. Edit invite. So no expiration, never. Generate a new link. Copy. And I need to edit the... Fuck. That's stupid. What the fuck? Hey, you will Adamas. Yes, it is. It's kind of if it's kind of Gucci. Actually, let me try to show it completely. Oh, you got it? Nice. So this is a stealth press. You can buy a kit for it on AliExpress or whatever. You can print parts. It's kind of a Gucci thing. But quality of life, this thing is amazing. It's everything. It makes everything so much easier to just press them straight. Even that this is a kind of odd part. But you have control on they get in straight, the depth, and it automatically goes up. This one it's actually not used in a while, so it's a little stiffer. But yeah, it's super fun. I need to change the wiring to a softer one like silicone, because this thing is super hard, especially now in the winter. So you can buy the kit. The kit is actually cheap. It comes, you can buy just the hardware or with the soldering iron. I really like this. Okay. Sure, man, go take your call. This soldering iron, it's actually quite good. You can set the temperature and whatsoever. Just don't do like me. It needs a little long to turn on the red button. At first, I thought the soldering iron was broken, but it's just it kind of needs a long press, like 5-7 seconds pressing to actually turn on. But yeah, and I forgot it on for at least 1 week, and it didn't die. It comes with the heat tool. Well, I mean the kit, because you can build it if you have spares. You can build it with spares. Now, I seen some nice jigs for tapping. I own a tapping arm on my main shop, so yeah, it's something I don't need at all. I'm not sure if this thing, because this is new, this is different. Oh, actually they finally listened to me. So now we need to insert them from the bottom, which makes sense. Okay, so this is gonna be a hard job. So actually I'm gonna do this one by hand. No, I don't like it. It's gonna be crooked. Okay, so let me get another iron to do this. Probably I'm gonna use our... This one is too small, I think. Yeah, this would be nice. Shit. For the... We don't really need it. Yeah. Okay, so I need... Okay, I'm gonna go there just to put these two. So these two will work better with the... Well, actually... Let me check what kind of tips I have on our super duper high quality super cheap soldering iron. Oh, we have the knife tip, so that I can make that work. Okay, so we're gonna use our battery operated super duper iron, which costs like 12 bucks. And let's drop the power to, or the temperature to 260. So it's heating up 100, 120. So 260 is the minimum it will go, so that's why. Otherwise I would go like something 240. It's what I have this one set. So we are at 240, which should be fine. So we can press this guy here on the side. Not too much pressure. Just enough. And there we go. So yeah, our super duper heat press, it's not like foolproof. There are some cases that the good old-fashioned soldering iron needs to come in. There we go. That's good enough. So this thing costs like 12 bucks. It only comes with one, I think it only comes with one tip. I'm pretty sure it does. But you can buy the tips for like 3 tips for I believe it was like 9 bucks or something like that. But it comes on this case. It actually comes with a support for it, which it's somewhere in my desk. I have no idea where. And it comes with resin flux, some solder, some shitty. This thing doesn't worth what it weighs. But yeah, it comes on this case. It's battery operated, USB-C charging. It works super well, and it's super cheap. I only bought it because it was so cheap and I wanted to try it. And to be honest, I used it a lot more than I was expecting to use it, because it's battery operated, so sometimes I need to go just solder a wire somewhere. I don't even need to deal with a power cord on it. If you want something a little better, you can join our Discord on link in the description, as I said. And I posted a link, but I don't think that one it's USB-C, but I don't think it's battery operating. This one is battery operating. I'm not sure about how much time the battery lasts. Can't be longer because it's a small battery. But yeah, this thing is super cool for the what it costs. It's a no-brainer. Yes, exactly. I am exactly like that. I am a complete tool addict. I am a super addict buying tools. And I bought. I have actually some streams speaking about that. Cheap tools. I bought a microscope, also super cheap, which works fantastically well. I have a trinocular one for my electronics repairs, but that one was so cheap, I actually had to buy one to check if it was exactly like that. A friend of mine bought one and he told me, dude, you need to check this out, this thing is amazing. And indeed it is. Okay, so we have more inserts in here. We have 2 in here and 2 on the front, if I remember correctly. Let me check. Yes, 2 in the front for the fan. And 2 on the sides for the actual yacht end. The actual yacht end. Let me grab my... Where is my... I'm missing my aluminum block. So I used it... Yeah, it's here. So I use this thing as a step for this kind of stuff. So since it's not flat on the bottom, I can step it. So one in here. And I really like to try cheap stuff. It's not because I'm cheap, it's because I don't like to pay more than I need for something. So if I can get it cheap and it works as I intended to, or as I needed to, why should I spend big money on something I can spend little money? So I like to try cheap stuff. That's why I bought the Knipex pliers clone, because the originals are very good. I can't recommend them enough, but they are expensive, and if someone needs it for this kind of stuff, for pressing magnets, for our light work with the 3D printers, I'm grabbing the 3D printed parts. Jesus. Yeah, I'm only grabbing one because the other one, it's too sticky there. I probably, since I have a little much to squish on my first layer, I'm gonna need to do some X-Acto work. Yeah, and especially I don't mind to mess with it, to actually to do some changes to make it work in my favor or somehow or somewhat. Again, it's not that I'm cheap, or it's not that I don't give it the value that it's worth. It may just not be worth for me. Again, on that, on the Knipex pliers, I have 3 of them, so of the original ones. So don't get me wrong, I know exactly they are worth what they cost, but I found that cheap version and I had to buy one to see if it's good enough for the price it costs, and I think it is. Is it the same as the original? No. But we are talking about a $50 difference on a $65 product, which is a shit ton. And if it does the job that we need to do, there's no need of spending so much money on the original one. And yes, of course, the original one had all the work, prototyping and designing and whatsoever, and I respect that, but it's the world where we live on. Yeah, it's gonna need some more work. It starts fine, it's just because I have the first layer, it's too squishy. I need to open the holes more. So that one should be fine. Oh, it's no longer available? Let me check. Let's check. Maybe they changed the link, and that link, because I saw a few of them. Let me go to Brave. Okay, let's check. So we should have in here an AliExpress. So let's call it plumber pliers. I remember use flat. Let's see. There we go. So this one works. You can check for other ones, but this one works. So let me copy. Oh, it's too big. The link is too big. So maybe if I use the share. Fuck. Except cookies. Okay. It should work, right? Check if that works. Otherwise, you know what I search for: plumber, pliers, flat, and you should get it. And there's a few of them, so not this one. I'm pretty sure there are more links to it, because I've seen a bunch of them. So yeah, here's another one. This one it's more expensive, but can be the biggest one, because there are multiple sizes. So this one I have, I think it's the 7-inch. This one I have in here. Yeah, okay, turn on. Let me check my account, my orders. So the one I bought, is it still available? Yes, it is. So yes, I bought the 7-inch, and it's this one. This should be so yeah, it's this one. So I'm not sure if these ones are parallel. So the thing with these ones is the jaws are always parallel. So they act as what we call an English wrench. So they are you see the jaws are always parallel with each other. So these things work for the X-nuts and whatsoever. These are awesome. Okay, let me grab my X-Acto again. I need a new blade. This thing is dull as fuck. That's why I'm having so much trouble. Let me check. So it should be like this. Yeah, it should be very close, so I now should be able to fit it with a flat. If I would buy one, I think this one, so the 7 goes up to 40 millimeters, I believe. The first I bought, it was a 6, which was kind of small. I think this one for our works, yeah, this opens up to 40 millimeters. I think the 7 is good, but the 8 will do will do the same as this one, but I think this one it's a good size for what we do, to be honest. But yeah, I don't know. Welcome back, my friend. Let me put in the part8 so I can push this thing on. Actually, that one it's a little small still. Yeah, I can see the edge there. That's fine already. No! Don't go away. Don't run away from me. So all this work I'm doing, it's because I'm over extruding my... I'm either over extruding or squishing the first layer. It's a little bit too low, which causes or maybe it's a little bit of both. Yeah, that's fine. There we go. And it squishes a little bit too much and creates a little edge, just a little edge, like a tenth of a millimeter, and that's enough for this perfect fit stuff not work. So we have the shielding on, and now this thing should be like this. Yeah, and I'm having the same problem in here. I need to cut down the little edge. More like a burr that it makes. So I need to tune my probably just a few cents of a millimeter higher on this printer. Yeah, that should be fine. And this thing is not symmetric, so you need... There we go. Now I need to push it in all the way. I need something like that. Yeah, that looks good. It should be flat. Do it yourself? Maybe. We already have, so there we are. We already have okay, so the wires are a little bit too big for this setup. So we already have, how do you call it, EDM machines, so nah, there's no side tracking. So let's put this thing to the work. So yeah, since we already have EDM machines, why not one day have addictive metal machines? So I don't see a problem there. Okay, so let's try to put in a grill. I printed 3 of them just in case, because, and I'm gonna cut the edges as well. I shouldn't, but I don't know if they fixed it. The last version, or the first version, had a little play on it, and I didn't quite like it. But let's see. I'm not sure if they fix it or not, so I'm gonna go with it. Just removing the edge a little bit. That should be fine. Okay, so the grill, it's a little bit tricky because it's too sensitive, too thin, and too tight. So it's a nice combo of everything which is good on plastic. Not subject to... Actually, I'm gonna remove... Let's see if I can remove it. I'm gonna remove the LED for now, if I can. I think I do. With a small screwdriver. It's probable. It's definitely possible. I don't see a problem with that. Okay, so I'm gonna insert this thingy after. Actually, I'm gonna chamfer the front a little bit. Make sure it goes all the way to the front. I definitely think it's very possible. With all the technology going forward, okay, let me move the wires a little bit from my LEDs. They are a little bit on the way of where the grill needs to go. I really don't want to break this side. These side tabs, because it's not the first time I would break them. Like that. Okay, let me try something else. Let's go with a pointy. Yeah, there. Like that, with a pointy first. Well, I don't know. I couldn't print it anyway. I couldn't make the bed adhesion on mine. Maybe it was printed, it needed a little more temperature to make the to make a little better adhesion. I don't know. Go down. You need to go down. Yeah, like that. Like that. And you need to move out of the way. Otherwise you're gonna be cut. Shit. It's cut already. Not the metal though. Go away, wire. There we go. This thing is a pain. Yeah, you need to go lower. There we go. Yeah, they definitely fixed it. Because it's definitely tougher to get in. Well, we either break it or make it. No, it was stress. It broke. Yeah, I can't even make it fit in here. Okay, so let me cut it a little bit. If I can remove it. Oh, okay. Now that I know that they made it tighter, I can actually play a little bit. Okay, so I'm gonna cut it like, shave it just a tiny bit. In here. Cut my edge. Because I have that little edge. I have it in here, so I'm removing it down. It's fine. Let's go. Try again. No, it broke again. At least from my understanding, it broke on the layer lines. Okay, so let's try it like this. Put it from the top. We have a spot for it down there? Kinda. Yeah, much better now. But still, I'm not sure. Okay. Think if they do a chamfer here on the design, it will make everything better. Let's see. I'm pretty sure this thing will never fit in here. I think it's too big. Well, I can make it fit. Yeah, it's just a matter of Portuguese persistence as usual, I think. Okay, I need... Well, it's a struggle. It's too tight. But at least there's no play anymore. Okay, I can live with that. Okay, I'm not sure where TrueRex posted the pictures of the fail, but let's analyze it. So I'm gonna share my big screen. And let me open the picture. Open in browser. Let's take a look. Oh, okay, so it actually broke. So it actually broke across the lines. I thought it was like something like delaminating. Well, the part looks too thin, doesn't it? Too shallow. Did you print this with the recommended? It looks beautiful, the print. Did you print with the recommended settings? It looks like... It's hard to see. But it looks like it doesn't have many parameters, right? At least it looks like. Which part is this? So this is from the Z, right? Yes, that's what I think. The infill looks like kind of shallow. Is this, so this is the other version, right? This is not the beta, the R1 beta, right? It's the default? Yeah, and even the outer wall, it looks like only a few perimeters. Okay, let me check. Let's check the Micron Voron. So STLs. So it should be on the Z, right? Z drive. So it should be either this one or this one, right? No, it's not. It's not this part, right? No, it's not this one. It's the... It's the NEMA 14. Oh, it's the motor mount. Okay, so it's the 14 or the 17. So it's not this one, right? Doesn't look... Or is it? Is it that? It's the NEMA 14 or NEMA 17 version, so it should post... It's probably... So it's probably there, right? Okay, 17. Let me close this one, this one. So 17, it's either these or these. So it doesn't really matter because probably they are just mirror it, right? So if I'm correct, so it should be this one. Hey Zero-Mix, how are you, my friend? Okay, so let's download it. Let's open Orca. Let's delete this thingy. Delete all. Let's import it. Should be on here on downloads. So it should be this part. Let's make it another color just so we can see it better. Yeah, it doesn't matter, don't care. So this is the settings for Voron. Let's slice it. Let me change the... I changed the infill on this thingy. And I saved it, my mistake. Let me put it grid. It's 40%, that's fine. So yeah, from what I see in here, okay, let's do this. And let's put yours aside. Where is it? It's there. So it really looks that your it doesn't have the perimeters, like, right? Doesn't look as thick as the, so, but this is not the same part. It doesn't look the same part, right? Yeah, this is not the same part. This is different. But I'm checking the, so it's the Micron, needs to be Micron Plus. No, it's this one, it's the R1. We have the R1 in here. Printers for ants. Repositories. Yeah, it's the Micron. Yeah, I mean, it's not the exact same. Oh, it's the 2.4, it's not the Micron. Oh, I don't know. Yeah, sorry. Yeah, sorry. So, yeah, my mistake, sorry. 2.4. GitHub, Voron 2, that's it. STLs. Yeah, since my mistake, sorry. So it should be one of the motor mounts. So it should be either one of these. Yeah, that's, well, even that's not the same. So this one, it's from the Micron, go away. It's not the same, it's not the same, it's not the same. It's the R2, this is the revision 2, pretty sure. There's not a new revision, right? So, pretty sure. Yeah, it's the Voron 2, it's the latest. Okay, I'm gonna do something else. Just to make sure, I'm gonna go Voron 2.4. And I'm gonna go to the Voron design. Nope, that's not what I, this is what I want. So the R2 here, it's gonna take me to the, oh really? Okay, let's go to cut. Okay. Yeah, it's the Voron 2, STLs, the Z drives, and motor mount. We have the A and B, doesn't matter. Yeah, it's not the same part, but anyway. Oh, I don't think it's the same part, at least. Well, maybe it is. Maybe it is. We can see, so it's actually this part. Let's do the same thing. Let's open it. Z motor. So yep, slice. So it's here. Yeah, that thing should be filled. That's, I'm pretty sure you fucked up with printing, with the printing settings, because that thing should be filled all the way. with plastic. That thing shouldn't be hollow at all. Even that, I think they recommend 4 layers, not 5. Okay, with 4 you should have a little bit of hollow space, but definitely not as much. I use 5 on my settings. So I'm pretty sure you messed up with the print. Maybe you had the wrong profile selected or whatever. But I'm pretty sure that that's not what it's supposed to look like. It's really shallow in here. It looks like this looks like 2 perimeters or something like that. 3 maximum. So I believe something went wrong on your settings. That's what I believe, and that's why what it looks like on the picture. Okay, so let's get back to this thingy. Yeah, it kind of looks good. It fit with a lot, but now at least now it doesn't move like it used to. So I have a few versions in here. Well, this one didn't move as well, but this one I modded it. But this one actually moved a little bit. So yeah. And I'm happy with all the strength, the force I made in here, and nothing actually broke. So I'm happy with that. So I'm gonna push in the LED again. It feels like it should go a little deeper, but okay. Can work with that. So we have the LED wires can come here for the channel. I'm using very thin wires, so let me remove this guy aside. We're gonna need it more, so no point on really. So my wires are definitely too big. But I don't feel like removing I could. It would be just a case of removing this LED and shortening the wires. But if I can make them fit, I will. I don't care. They could be like 1 centimeter smaller. What we need to do, I need a fan for this thingy. So this one is GDS time, which I'm not gonna use, but I want the screws. So I'm gonna remove the screws. I want a delta. For this build, I'm gonna remove this one as well, because we're gonna need it. The big fucking screw, where shit. Okay, let me grab a fan. What time is it? Oh, time to, let's finish this, or try to. Okay, so I need a delta fan. I have these GDS that we're gonna need them as well. I think this one it's the same. Yes. No, the default from Voron, it's like 4 perimeters. Pretty sure. I'm pretty sure the default from Voron, if we go here, Voron print settings. So yes, you have wall count, it's 4. Oh, sorry, you guys are not seeing. Well, I'm gonna do it again on Brave. So Voron print settings. So this is the Voron print settings. Wall count is 4, as you can see there. Oops. And if we go to Voron documentation, here they are, Voron print settings, layer height 0.2, extrusion width 0.4, forced, infill percentage 40%, infill type one of these, wall count, which is perimeters, 4, and solid, I actually use 5 on all my printers. On solid top, bottom, 5, and no supports. So here are the print settings. I can share the link. And actually I use 5. There's nothing wrong on using more on solid top. So basically they want at least 1 millimeter on top and bottom shells, and at least 2 millimeters on well, 1.6 millimeters actually on walls, because it's 4 times 0.4. I think I use 0.45, but 0.4 it's the what they do the designs according to. So yeah. Okay, so this doesn't matter. Oh, I was looking for the fan. Okay. Where is my fan? Nope. Ah, here he is. So actually I have delta fans for the side thingies as well. I'm gonna use those. I like those. Oh, I'm not sure if I have. Well, I have one. And I have two Sunons. And I'm gonna use my delta. Yeah, the delta is the way to go. Not really. On the STLs, they don't change the wall thickness. The only way to change the wall thickness is either if you hollow the part itself, which they don't. So if you make like if you create a void inside the part, which they don't, or with the perimeter number. If you decrease the perimeter number, you're going to increase the infill, and therefore you're going to decrease the wall thickness. Because if I do, if we go, where is my, yeah, it can be Orca. If we go here, so now I have the four perimeters. So it's the wall loops. It used to be perimeters on Super Slicer, Prusa Slicer, I don't know what it calls it, but if I go 2 in here, enter, and if I do a slice, see, now we have something like he has on the picture. And if we do the 5, that's my default. Now we have much thicker walls. Yes, but that's the printer. It depends on the profile. If I use my default profile for, actually I don't think I have a default like for silk, for instance. So I use these for like beautiful objects. I'm gonna discard everything. So here I use only 3 top shells and 3 wall loops. So if I do this, it's the thingy. So, but all my profiles, I pretty much build them. So if you use like the default, well, let's say, if you add a printer to your slicer, let's try to do that. Let's try to add a printer here, like a Voron. A Voron Trident 350 0.4 0.4 nozzle. So it should come here. Yes, it's here on the, but I'm not sure. Let's see. So this is the system presets. So let's see what this calls. So the standard at Voron. So this is a system preset. So it's it's the profiles you get from Orca, the default ones. But this is not the default printing settings for a Voron printer. So this is just a standard Voron profile from the slicer, which is actually 3 wall loops. But this doesn't mean it's the recommended printing settings for printed parts. The default settings for the printer parts are actually what they describe in here. So this is the print settings they recommend for the 3D printer printed parts. This is nothing to do with the default Voron settings on a slicer. I'm not sure if I'm making myself clear. Just because the default settings on the slicer are these ones, this doesn't mean it's the recommended printing settings for the actual printed parts to build a printer. The recommended printing settings are these ones. So you need to change the profile, or create a new one, or just change the settings to these to print the parts. Yeah, I understand that you do. I just want to make myself clear so everyone see the standard profiles on a slicer doesn't mean it's even they are for a Voron. It's just the standard profile. It doesn't mean it has the settings properly set to printing parts for a printer. That's all that matters. That's all I want to say. You need to change the settings accordingly to the needs or the strength. You see, it's actually on the strength section of the slicer. So if it's only a static object or something that needs to be beautiful, doesn't need to do. It's just how do you call it? It's not a functional part. It's just something like a toy or something that just need to be pretty. Doesn't need to do any force at all. You can go here and go with just 2 wall loops, infill just like 5% and whatsoever. So you save plastic, but because it doesn't need to be strong, it only needs to be beautiful. Or it only needs to have a shape that will handle no force at all. So you can change the settings accordingly. But when it comes to building a printer, they have the recommended settings for that. So it makes sure that it will handle the stresses and the forces and whatever just fine. And actually here, this one is very important, because they make the parts when they design them. Sometimes they design it specifically with this number, that can make the difference of being a wall in somewhere and no wall at all. Because if you set these for 0.5 for instance, and the design actually have a 0.4 millimeter wall, you take the risk that the slicer, when it's slicing, it says, okay, so we are slicing 0.5 millimeter walls, and the design actually requires a 0.4 millimeter wall. So since we can only make a 0.5 millimeter wall, yeah, maybe we won't put a wall at all in there, because they require 0.4 and ours is 0.5, so it doesn't fit. So yeah, let's clear it and let's not make a wall in there. While if you have it a 0.4 millimeter wall and the design requires a 0.4 millimeter wall, so it's right on there and it's gonna put it there. So yeah. So yeah, that's what everyone should do. Just make a user profile with the settings they require, and every time you need to print parts for a printer, you use that profile, and that's exactly what I have here. So these are the system presets, and these are the user. So these are my own designs or my own presets, and I have the standard. When I have the standard Voron here, I actually have the settings for the Voron, the Voron parts. And it's pretty much, to be honest, I pretty much only print like strength parts and functional parts. I pretty much always use this profile, and it's actually conservative in speeds, because when you're printing printer parts, you really don't want to go very fast. You want to go a little slower, so the plastic actually settles well and whatsoever. So I'm actually conservative on my speeds, and I even have the quality, slow and quality. These all have the same strength settings. As you can see, 5 walls, 5 top, 5 bottom, gyroid, which is a nice infill, 40%. All of these are printer settings, and I'll just go slower if it's anything that I really want to be spot on. So yeah, that's the process. Oh shit, I'm not showing anything. Sorry, I thought I was showing the my slicer. So yeah, so I have all these profiles that are my own. So I have this one for TPU. I have this one, it's a 0.5, so it's for a 0.8 nozzle, for fast stuff and dirty. And I have the quality, it was what I was saying. It's just a little slower, so I can have better printer quality. And I even have the quality slow, which is something that requires to be slower. But yeah, pretty much everything I use is the standard. And I have this one, which is the fine pitch 0.12 layer height for that stuff that needs to be really detailed. So yeah. Anyway, it's time for me to go to sleep, and we did almost nothing again. But yeah, I'm gonna just go a little more. So this is a Delta fan, 25 millimeter. These are supposed to be the Ferraris of the 25 millimeter fans, which should go in there like that actually. So we need to put 2. Well, I appreciate the appreciation, and that's honest. I'm not making fun or anything, because it's good to know that someone is getting something from me talking. A Portuguese guy that speaks bad English and makes streams for hours because he thinks himself is a YouTuber. So we have that in there. Yeah, that makes sense. Okay, so this is supposed to have slots for the screws, but I think if we actually do some chamfering on the fan, so I use this, but you can use just a regular 90-degree chamfering tool. And then if we use countersunk, oh shit, these things don't fit in here. I wonder if these are supposed to be 2.5 millimeters. I wonder that. So these are, where is my calipers? Should be here. Well, should. Just because it should, it doesn't mean it is. So it's actually the first time I'm using these fans. If you haven't noticed. Oh, it's there, under my phone, actually. Oh yeah, these things are 2.5 millimeters, 2.6. So it's reamer time, because I don't have, well, actually I do have, but I already put these things in here. So I'm gonna grab a reamer, and either I'm gonna fuck up a fan, or, so it should be this one, right? Yeah, 3 millimeters. Let me grab my end tool. So yes, you can use a drill. You need to be careful, because the drill can go away from the hole, while the reamer will follow the hole straight. And nowadays a cheap reamer is cheap. Or better saying, there are cheap reamers. I like to do this stuff. You can use a power drill. I like to do this sensible stuff by hand. Where is my chamfer tool? Okay, so I'm used to look for, oh, it's here, for a blue tool, because usually these blue Nogas, the Noga stuff is blue, not this one. Okay, so now we are good, and we don't need such a big screw, maybe. Not sure if, probably this is too big, we'll see. Which one? Okay, this is the Philips one. Where's my... Oh, it's here. Yeah, you need feedback. You need the fingers feedback to actually... okay, it needs to be smaller. So these are probably 16 millimeters. I need to... Oh shit, I don't have 14 millimeters countersunk. I'm not even sure if I have any in here. Countersunk M3. I have downstairs. Actually, I do, but I only have 12s. I'm not sure if 12s are long enough. Not sure if 12s are long enough. So probably I'll need to chamfer a little more. Because if I chamfer a little more, they'll go a little deeper. Again, where is the black stuff? Here. As long as it doesn't go to the blades, we are set. And we are reaching the blades there. So yeah, we are set. Let's see. Yeah, this thing is too small. Oh, motherfucker. So, how long is this? So this is 10. Okay, so I need 12s regular. I could grind the 16s a little bit. But I would need to go downstairs for that. And maybe I'll save it for next stream. So probably tomorrow we're gonna continue. And yeah, so it's late already. It's 1:30 a.m. Here in Portugal. So yeah, I'll cut a few millimeters of these in order to make them fit. And we should be fine. Just because just because why don't they make a little bit of, well, I could do that myself. I could drill it. I can do that. I can drill a little bit past the heat set. So let me grab the 2.5 millimeter drill. Actually, if the 2.6 fits there, let's check. It does. Can actually use a 2.6. So what I'm gonna do, I will just drill past the plastic because we can, I think. Not that much. Looks like I found the aluminum of the hot end already. Let's see. Wrench. So I can feel the plastic. Yep, that works. That works just fine. And this way we don't need to shorten our screws. This is something that doesn't hurt at the design, and I don't understand why they don't do that in the first place and save us all the problems with that. So now this thing, should be in here. Let me try to understand where the fan wires can come. Okay, so from my understanding, let me remove the screws once more. From my understanding, the wires can come from here, so that means that we need to rotate the fan, and the wires actually need to come from here. Or maybe from the side. Let me check how this fits in here first. Okay, so this fits like that. Okay, so probably the best way, yeah, it's the fans, the wires to come from the side like that. So it means I need to chamfer another another hole, this one. That's fine. Fuck, and I need to, yeah, I need to drill the... I need to enlarge the other one. So it's this guy. Like that. Like that. I don't even know how this fan works. Because it's 3 wires. I think it's I'm not sure if it's a tech. If it has a basically a speed count, yeah, a speedometer, something, a tachographer, which is the exact name, or if it's PWM. Anyway, let's see now. So in theory, it should be like this. So the wire should pass on that hole and go like that and fit like that. That works fine. LED wires don't, well, actually they show up there and I don't like them there. Let me push it away. Yeah, that's fine. Everything looks good, so I assume we got 2 screws there. These look like M36s. Something like that. M35s, 36s, button heads here on the side. And I need the blue one, so this one. Like that, and like that. So now the, not sure, maybe the vent fans, probably. Okay, so this thing is take a heat set there. I think it's supposed to get a magnet in here, but I don't need a magnet. I think this is for the stealth change. Is the camera focused? I can't actually see if it's focused. Let me try. Oops. No. Let's make it bigger. Move the shot window here. Let me check. Like that should be fine. Okay, so let's put in the heat set there. And we have another one. So heat set there. Now, so this thing is supposed to get these fans, and but you are supposed to remove the leads from the fan in here. So for that, you just push the lead out, and you should just slide it in. There's a two spots there to put a screw. Supposed to be a M2 by something small. So let me grab that. A self-threading screw. So I'm gonna try M2 by 4s, which are really small. Probably by 6s should work better. Yeah. So a few of these. Yeah, these guys. So let me move this thing away. So you have more space in here. Okay, so let's try. Let me grab my. It's here. So let me remove the Torx and get Phillips, which is the head for these little guys. Let's see if these are not too long. Yeah, they look nice. Yeah. I know the feeling. I know the feeling. Like that. So the other side. So I actually haven't, I think I placed them well. Let me see. Yes, so you want to make sure you have the venting side to the bottom. So this guy, in this case, we have the vent holes in here. So we want the whole, the open side to there. It helps. Okay, so now we are building a printer, but on this channel we do a lot of stuff. We repair electronics, we build printers, we build CNC machines, we do a lot of stuff. So after we finish this build, we're gonna start, we do CAD, we do CAM. After this series, we're gonna start with a CNC build, a Milo build. Is it me? Or let me check before I speak. Let me check. I'm pretty sure the nozzle is lower than the... So yeah, I need to change the mount. I'm not sure why. Hey, Anthracite Project, how are you, my friend? So, yeah, I need to change it. Fuck me. Again. So this is supposed to be a TZV6, I think. But you remember when I said it was the same size of the Dragon? So looks like... I'm gonna need to change this thingy. Because this one actually sits the hot end lower. And yeah, but that's gonna be for tomorrow. Because my... Not sure if I can show it. My hot end, it's actually lower than the ducts. So I need to change the mount. Which could be worse. But yeah. I think this one is the V2. I had it for a while. Let me check the box. I think the box is on the... I haven't checked the V3 yet. I didn't even knew that there was a V3. I'm using the V2. Oh no, I don't yet. At least yet, I don't do resin printers. I never done. I don't have a resin printer. Okay, so this one, it's an old one. I'm pretty sure I have a better one. Yes, it's in here. So this is a newer one. Newer version, but it's getting late, so I'm gonna put in the... Oh, it's just these two, right? Oh no, two on the sides, two on the front. But I need to drill... Oh. I don't even know what's the difference between the V2 and the V3, you know? I never used these V6 like. I used the bamboo likes, not these round heatsink ones. So this is what happens when we don't have a manual. It's just blind, and when the guy doing the stream doesn't care a shit and try to figure stuff out before. No, I don't have. I checked. Actually, I checked the. It's not. I have 2.5 millimeters. 2.5 millimeter heat certs, but they are thinner. They are not the same. They are not the same. They are not 5 millimeters, I think. These are 5 millimeters, and the ones I have from, yes, these are 5, and the ones I have are 4 millimeters, I think. Yep, these are way smaller. So these are, yeah, these are 4 millimeters. So these don't fit in the in the yeah. So these won't fit in that project. So I'm pretty sure the workaround is to use the 3 millimeters and increase the diameter of the fan. Oh, but I need to drill them, right? Because of the screws. But for that now, I'm gonna use actually the drill, because I don't have the hot end in there, so I can go just blast full power on the plastic without worrying of eating the hot end. Okay, so let's remove the thingy again once more. Now that I'm seeing, this needs to be attached after, right? Yes, because we need to put some screws in here to attach to probably the carrier. And then we attach the rest of it. So we need to remove the fan. Yeah, it's time for me to go, really. It's actually past time. Need to work tomorrow. But yeah, at least let me change this and set this part to recycle the... So maybe this is set for the V3, and the V3 it's a little longer. Maybe, I'm not sure. Maybe the V3 has a longer heatsink. Who knows? Yeah, so I hit the heatsink with the drill before. Not now. Actually, I can save this part, because this part is all good, except it's not for this hot end. Maybe one day I'm gonna get a new hot end and it will fit or not. Yes, we could make a spacer for it, a 2 millimeters, even a 1 millimeter spacer would work. It was pretty much on the same level. The the ducts and the nozzle. So I've made a designed so many extruded and dot end combos in the past between Vicor, VZBot. I like to try new stuff. Well, and I really liked and I actually helped designing this one, the Antet, which I would really like to try. So why not? Okay, so I'm gonna assemble these, but I'll need to disassemble it anyway, but... Oh, we need a fan. Yeah, 2.5 millimeters. The screws are... Well, they are what they are. I use them for work all the time. Like that. Looks fine. So the wires should come here on the side. And like that. Again, these are gonna need to be all disassembled because this thing is supposed to be attached to, so this part with the hot end, I think it's supposed to be attached directly to the carriage, and then we build everything around it. But so for now I want to see if everything is fine, and I need to do all the crimping for the toolboard, and it's nicer to have just to see if everything fits and everything goes where it's supposed to. So this is like that. Then we should get this thingy on here, all the wires on that channel, something like that. Oh, thank you, my friend. So I assume we need some M36s there, which I don't see. I see M38s on my... I see a lot of M38s, but not M3... Oh, I see one, which will work for now. Probably it's actually an M38. Now that I'm kinda... Nah, it's an M36. Oh, of course. I need to fetch the LED wire, which is showing here on the front. And I really don't want it here. Yeah, looks good. Looks good. No M37s. Well, they sell M37s. It's called M38s with and the angle grinder. That's what they're called. They are not called M37. They have a different DIN reference. It's an M38 with an angle grinder. It's what they call two M37s in here. Well, it should maybe it would fit an M38. Let's check. A file is too much work, my friend. I'm too old for files. Angle grinder to the rescue. Let's see. Yeah, it fits an M38. It's not... Yep, M38 fits just fine. At least on this one. Let's see on the other side. So this thing, it's actually well designed. It latches on the back, on the bottom, sorry. And is this thing well... Okay, this thing is well, this thing is not well. Okay, it's pushing a little outside, but the screw will push it in back in. Yeah, it's fine. And yeah, and now I have the hot end is fine. So let's see. If the M38 motherfucker. And of course it needed to go under the wheel of the chair. Yeah, the M38s work fine. So it can be either M36 or M38. Or, and of course an M37 would also fit if you find one. So let me actually remove this one, because I have a lot of M38s. Well, I have plenty of M36s in a drawer as well. So yeah, this thing fits just fine. Everything fits fine. Finally, about fucking time. Now, if I remember correctly, we get this guy here on top. So what I can check, actually I need to pass the drill in here, just to clean it up. Yeah, that's for tomorrow. We need some stuff for tomorrow. We're gonna finish this thing tomorrow. So we're gonna assemble the extruder tomorrow. I'm pretty sure I have somewhere in here. So this is a dummy carriage. I have the CNC version. So this is supposed. Okay, yeah. So this thingy, it should. Emphasis on should. Yeah. So probably it can actually fit like this. Maybe, I don't know. We'll need to check on the origin, on that one. If I can go like that, or if I need to go somewhere else. I need to get yeah, I need to assemble this thingy, and we need to finish it so I can see where the board is, the tool board. So this should be something like this, and that's fine. It would be fine, but that's fine. It would be better. That's a good advice, but that's fine. It's pretty smooth. Everything it's actually my printer is pretty much dialed in. I usually pass a file on this surface because of the little. I will do that tomorrow when we assemble the extruder. But it's pretty smooth. But I like because of the nozzle, the lines of the nozzle should be. Yeah, I need to check that, so I can check it with this caliper, but I can check it with this one. So this one is an analog version, and the thingy, it's too thick. You see, it's much thicker than that one. So, but this one will fit in. So this one should be down there. Fuck. It helps if we turn it on first. Fuck. It helps if we put in a battery first. Well, actually it has a battery. No, it doesn't. So I need to bring a battery tomorrow. I could swear this thing had an O-ring. Probably add is the keyword. Doesn't have anymore. That's weird. Well, it's not working with coolant anyway, so. Yeah, I need to bring a battery for it so we can measure the. Well, I can roughly measure it. So we have, no, it's way more than 20 millimeters. So 25 here. And here we have something like I don't know, 7, I can do something. Yeah, 7, spot on. So we have 7, we have 32 millimeters. You said 22, right? So it's 32 millimeters. Yes, it's 32. So that's it for today. I'm tired. It's late. We did next to nothing again. So yeah, that's the thing with, let me aim on a little higher. That's the thing with no documentation and just going blind into stuff. Takes a while. And when the guy forgets to print parts, it's the same. So yeah, I'm gonna turn off this thingy. I'm gonna turn off my V0. This guy is drying, let it be. Actually, it's dry already, but... And yeah, so that's it for today. Tomorrow, I'm gonna try to stream tomorrow again. I really want to get this machine going. And since we are doing huge progress on these streams, huge, I want to keep it going. So yeah, this is the worst part when you're figuring out stuff and whatsoever. Should go smooth after that. Thank you guys for watching. See you guys tomorrow. I'm gonna get some rest. Tomorrow it's a big work day. And thank you for the company. Please like and subscribe if you like the content. And good night and see you tomorrow. Take care. Bye bye. Thank you all.